Today we are going to do 5070 variant 1-2 October November 2021. The specification of this paper is that it's an MCQ paper, paper 1, and it's a 1 hour paper with 40 MCQs. And it's a multiple choice paper. So you are given A, B, C, and D 4 options. Out of these 4 options, you have to choose the best answer. So now let's start with the paper. Now this paper, it has 40 questions. Let's start with the first question. Now it says the question number 1 says, in a titration, 25 cm cube of sodium hydroxide is transferred into the conical flask. A few drops of indicators they're going to add into the conical flask. Dilute hydrochloric acid is added to the flask until the end point is reached. Which piece of apparatus are used to measure the volume in this experiment? So this is the titration experiment, and they have already said, so for the titration, we require the burette and the pipette for the accuracy. So to measure the dilute hydrochloric acid, which they are going to add to the flask. So for that, we will be looking for the burette, either A or B. And they are going to take 25 cm cube of NaOH, which they're going to transfer into the conical flask. And for that, we will be taking the pipette. So according to that, the correct answer is going to be your B, right? Because it's a titration. So for accuracy, we are going to have pipette and burette for the measurement. Moving on to the question number 2. For the question number 2, I want the whole question to appear on the same page. That's why I'm reducing the size of the page. Now, the question number 2 says that a student followed the rate of reaction between the marble chips, that's calcium carbonate and hydrochloric acid. And this is a reaction. Calcium carbonate and hydrochloric acid reacts together to give you salt, carbon dioxide, and water. Now, which diagrams that with a stopwatch is suitable for the experiment? They're asking that which setup is with which setup you are going to need the stopwatch, and why do you need the stopwatch to measure the time? So it's a gas collection. We are getting a gas here, the carbon dioxide. So the volume collection against time, you have to have the data, or the calcium carbonate being used up against time. तो दो चीजें आप measure कर सकते हैं यहाँ पर rate को check करने के लिए. So experiment 1 में आप gas को measure कर रहे हैं, and you're collecting the gas in the measuring cylinder. We will be needing a stopwatch here because we are going to collect the data, the volume of the gas against time. So 1 में आप definitely use करेंगे stopwatch, ठीक है? Now similarly for the second one, again you will be using a stopwatch where you will be checking the decrease in the mass of the marble chips, because here what's happening here, the carbon dioxide is not trapped within the setup. The carbon dioxide is allowed to escape out because they have a loose plug here over here, and this loose plug is of cotton wool. So according to the experiment, you're getting a gas that's carbon dioxide. It's not trapped within the system. It's allowed to escape out. So what is happening here? The marble, the overall the mass of the system, because the carbon dioxide didn't escape, so mass is going to decrease, and that decrease in the mass we are going to monitor against the time. So yes, we will be needing the stopwatch here as well, because we will be having the data. We will be observing the data against time. But for the experiment 3, which is a clear-cut apparatus setup for the titration experiment, and for the titration, we don't have to measure anything against time. So for the experiment 3, we don't require the stopwatch. So we'll be needing the stopwatch for experiment 1 and for the experiment 2. So let's see which is the correct option for 1 and 2 only. So our correct option is going to be B. Moving ahead with the question number 3. Now I'll again increase the size of the page so that everything is visible and obvious. The question number 3 says that pure oxygen is needed by many industries. How is pure oxygen obtained in the large amount for such uses? and we have studied this in the air and environment chapter, that the oxygen we get it by the fractional distillation of the liquid air. So oxygen for the large scale purpose, right? So we will not get it by the decomposition of calcium carbonate. Basically, decomposition of calcium carbonate will be giving you calcium oxide and is going to give you carbon dioxide. So A is out of question. B again is going to give you a small amount of oxygen there. C by the filtration of the liquid air, again no. And D, yes, by the fractional distillation of the liquid air, we will be getting oxygen. So our option D is the correct answer. Moving ahead, we have the question number 4. Now, question number 4 states that an impure sample of a compound X has a melting point of 120 degrees Celsius. X is purified and its melting point is measured again. Now, before looking at the option, let me tell you, the impurities always increases the melting point and it decreases the boiling point. So whenever the impure substance is there, so it increases the melting point and the impurities always decreases the boiling point. So looking at this particular concept, so melting point of the impure sample will be definitely will be more than 120 degrees Celsius because you have impurities present in it, right? So which row is correct? So we are not going to have a lesser melting point than 120 because आपका boiling point जो होता है वो reduce होता है impurities add करने पे, but the melting point always increase. So either C or D will be the correct answer. Distillation or crystallization. You have the option 125 degrees Celsius, either crystallization or distillation. Now they're saying it's a solid sample, so we'll be using the crystallization. By crystallization, the pure substance can be crystallized and it can be scooped out from the mixture. You'll be using the process of crystallization. C is the correct answer for this. Coming to the next part, that's the question number 5. When we talk about the question number 5, it says that when aqueous sodium hydroxide is added to an aqueous compound X, a red-brown PPT is formed. When dilute nitric acid is followed by the aqueous barium nitrate is added to an aqueous compound X, a white PPT form. So this is a very big clue that when you add barium nitrate and you're getting white PPT, so that means this is telling us that the sulfate ions are present. And the red-brown PPT being formed, that is an indication that you have iron 3 present. So we will be having a salt with the iron 3 and sulfate. So D is going to be my correct answer, which is iron 3 sulfate. Moving to the next question. Question number 6. An aqueous solution of zinc chloride is tested by adding reagents. So these are the reagents of the chemicals. So reagent means adding a chemical, right? So these are the reagents which are being added to zinc chloride, and this on the second on the other in the other column you have observation related to whatever the chemicals you are adding to it. Now it says that which observation is correct. So if you add barium nitrate, acidified barium nitrate, you will be getting white PPT. Now it's zinc chloride and white PPT with the zinc, with the barium nitrate, you will get the white PPT of the sulfate. So A will not be the correct answer because यहाँ पर अगर sulfate होता है zinc sulfate तो वो आपको white PPT दे सकता है. Coming to the second part, with the aqueous ammonia, you are getting white PPT, which is solvent excess of the reagent. Now that is a test for the zinc ions. So zinc ions are actually tested with aqueous ammonia. So when you add 5 drops of aqueous ammonia to it, you will be getting white PPT. Sorry. And these white PPT, they dissolve when you add excess of aqueous ammonia to it. When you add excess of aqueous ammonia to it, these white PPT, they dissolves, giving you a colorless solution. Dissolves to give you colorless solution. That's an ionification test for the zinc ions. So B is a correct option, right? Now, why C is not correct? That is also a reagent to test the zinc ions. With the sodium hydroxide, you're getting white PPT. And these are in solvent excess. So with the NaOH, for the zinc and for the aluminum, they both get dissolved in the excess of NaOH. So that is, this particular part is not true for sodium hydroxide. And then powdered copper, if you're going to add the powdered copper to zinc chloride, the copper being less reactive will not displace zinc ions from the zinc chloride, so forms a gray precipitate. That is again not possible. So we have the answer B here, which is correct. Moving to the next question, that's question number 7. A sample of the gas is released at a particular point in a laboratory. A detecting device is placed 10 meters from the point where the gas is released. This device detects and records the time when the concentration of the gas is 10 molecules in every million molecule of the air. The experiment is carried out with the two gases at the different temperatures. Now, those two gases are your sulfur SF6 and CO2. Okay, it is sulfur hexafluoride and it's carbon dioxide. Now, in which experiment was the time recorded by the detector greatest? So, time recorded by the detector greatest, that means they're talking about the diffusion of the gas. So, कौन सी gas इसमें से diffuse slow होगी? Because जो diffuse slow होगी वही detector तक पहुंचते पहुंचते it is going to take time. So it is going to take greater time to reach the detector. So the diffusion of the gas जो जिसका slow होगा, that means उसका MR जो होगा वो greater होगा. So what we are supposed to do is we are going to calculate the MR of both the gases. For carbon dioxide is 44. For SF6, we have the atomic number of sulfur, that's 32. And fluorine, it's basically 6 times fluorine, that's 19. So that's definitely greater than 44 when we simplify it. So SF6 sulfur hexafluoride is definitely either one of these options is going to be clear. So which is going to have a slow diffusion? So the gas at a lower temperature will be having slower diffusion. So for that, we have an answer for question number 7. We have an answer A, right? Because at 40 degrees Celsius, its particles are going to acquire more kinetic energy, so they are going to move faster. So B is not the correct answer. A is the correct answer. This particular gas at 20 degrees Celsius is going to take longer time to reach the detector. Coming to the question number 8. Question number 8, they have given us a table here. Table for some particle, we have a sodium ion, we have fluoride ion, and we have the magnesium ion. Sodium ion, and we have fluoride ion, and we have magnesium ion, right? Now, the proton number is basically the atomic number. The nucleon number is also given to us, and the number of protons is going to be the same as number of protons. Or proton number means the same thing. That is basically your atomic number, right? So this is atomic number, which is the number of neutron. When you sum up your number of proton and number of neutron, that makes your nucleon number, and nucleon number is your atomic mass. Okay, this is your atomic mass. So when you subtract the atomic number from the atomic mass, you get the number of neutron and number of electrons. Because it's an ion, so you have to check it out whether it has lost an electron or it has acquired an electron. Accordingly, you will be having the number of electrons. So now what we have to do is we need to find out the value for W, X, and Y. This is basically my W. So W is for sodium ion, and you need to find out the number of neutrons. Now, for the number of neutrons, what you have to do is you have to subtract the proton number from nucleon number. So 23 minus 11, I'll be getting the answer 12 here. So W is going to be your 12. Now we need to find out the next is X. So X is for fluoride, and you need to find out the number of electron. So it has one electron more than the number of protons. So number of protons is 9. So number of electrons will be 10 because it has acquired one electron. Now we need to find out for Y. So Y is basically the number of protons. So the proton number or the number of protons means the same thing. That's 12. So on the basis of this, we have got the W is 12. X is your 10 and Y is your 12. So our correct option is basically C. Moving ahead, we have the question number 9. And the question number 9 states that a covalent compound P has an empirical formula CH2O. So what is an empirical formula? Is a simple ratio formula. It's a simple ratio form of the formula. Okay? So what we need to do is we need to find out the actual molecular formula by adding all the atoms of an element and then simplify it. So let's do it. So how many carbon atoms do we have? 1. Oxygen, hydrogen are basically 2 and oxygen is 2. We cannot simplify it. This is the simplest form. Coming to the second one, we have again carbon 2 and the hydrogen are altogether 4 and oxygen is 2. We can definitely simplify it. And on simplification, we get the answer CH2O. And this is what they are demanding. So the one with the empirical formula CH2O, you have to find out. So that is an answer B. Coming to the C part, let's check it out again. This one as well, it's going to be C2H4O. So this remains the empirical formula because we cannot further simplify it. Coming to the D part, we have C3, H5 and 6 and O is basically 2. So again, this cannot be simplified. This is for itself is simplified. We have the correct option. That's basically B. Moving to the question number 10, it says that which statement about the structure or the bonding of the metal is correct? So the part A, it says that the metal lattice consists of the negative ion in the sea. It's in the sea of electrons, not the negative ion. These are basically the cations which are in the sea of electron. So A is incorrect. We move on to the B part. The electrons in the metal move randomly through the lattice. Yes, they move randomly throughout the lattice. So B is correct. Metals are malleable because the ions are present. They are mobile. It should not be the ion. It should be the electron. That's why the C is incorrect. The ion and the metal move when the positive and the negative electrons. Again, the ions are fixed. They are not mobile. They do not move. So that's why the C is incorrect. Again, moving to the question number 11. So question number 11 states that the relative molecular mass of chlorine is 35.5. So chlorine's AR is basically 35.5. Now they're asking what is the mass of 2 moles of chlorine gas? First thing is that we need to understand that the chlorine gas is Cl2. And they're talking about 2 moles of chlorine gas. So the MR of chlorine will be 35.5, 2 times, that is basically going to be 71. And 2 moles of chlorine will be, it's going to be 2 times 71. So the answer is going to be D, that's 142 grams. Coming to the question number 12, we have question number 12 states that when gas reacts, the volume of the gaseous reactant may be different from the volume of the gaseous product. Okay, for which reaction is the percentage change in the volume of the gas largest? So where you will find the volume change largest. So volume depends on the gaseous component. So we will only check the gaseous component. In A part, we have 2 moles of gas here. We have 1 mole gas here. We have 2 moles of gas here. So basically, there's a ratio of 3:2, right? So there is a difference of 1 volume only. Coming to the next part, B, we have 1 volume. We have 2 volumes. Basically, 3 volumes is giving you 3. So there is no change. The volume of the reactant is same as the volume of the product, right? Coming to the next one, we have 1 and 3. That makes it 4 volume here. And again, we have 2 volumes here. So up till now, the maximum percentage change in the volume is seen in the C part. let's see, check it out. The fourth D part as well. We have 2 volume and 7 volume. That makes altogether 9 volume, right? And then we have 6 volume and 4 volume. That makes 10. So there's a difference of 1. So here there's a difference of 1. Here there's a difference of, there's no difference at all, 1 volume. And here again, there's a difference of 1 volume. So the maximum volume difference is seen in the C. So C is the correct answer. Moving to the question number 13. Question number 13 says, sodium carbonate react with a dilute hydrochloric acid, and this is the reaction which is given to us. A sample containing 0.080 moles of sodium carbonate is added to a solution containing 0.100 mole of hydrochloric acid. Which volume of carbon dioxide is produced? Now, we need to understand one thing, that they have given us the moles of basically both the reactants. The sodium carbonate is 0.080 and HCl is 0.100. So whenever they give you the moles of both the reactants, then definitely we need to check it out. They both are not going to react. They are not going to be in the right proportion. Maybe out of these two reagents, one is an excess and another one is a limiting, right? So we need to find out which is a limiting reagent so that we can proceed with its moles to find out the product. Now look at the ratio here. They are reacting in the ratio of 1:2. So definitely if you take 0.080, you'll be needing twice the number of moles of 0.80. That will make around 0.16 something, which is not here. But if you will take 0.10, then you will be needing 0.05 here. 0.05 here, which is definitely here. So we'll say that sodium carbonate is an excess and our HCl is a limiting reagent. So on the basis of the limiting, and we always ignore the excess reagent. We always ignore the excess, okay? So we will be proceeding with our calculation considering the limiting reagent. So limiting reagent is basically 0.10, but these are 2 moles reacting with sodium carbonate. Now, let's check it out because we need to find out for carbon dioxide. So we have a molar ratio of 2:1 here. So 2 moles of HCl, which is making 0.10 moles, is basically producing 1 mole of carbon dioxide. So half of that will be 0.05 moles. So considering 0.05 moles, we'll multiply that by 20 unit is dmq. So you will multiply that by 24 dmq, we'll get the answer that's 1.20 dm cube of carbon dioxide produced. So this was a question related to your limiting reagent. Remember, whenever we get the 2 quantities of both the reagents, we have to first check it out, which is a limiting and which is an excess, and then proceed our calculation considering the limiting reagent and ignoring the excess one. All right. Coming to the question number 14, it says that which statement about the electrolysis of the solution is correct? Electrolysis of the solution is correct. During the electrolysis of concentrated aqueous sodium chloride solution, hydrogen is given at the cathode. Now, because look here that they're talking about sodium chloride, so they will be having sodium ions, chloride ions, H positive ions, and OH negative ions. There's a big difference between sodium and hydrogen. So no matter sodium is concentrated, but hydrogen will be discharged, right? So at the cathode, the hydrogen will be discharged. And at the anode, because there's a less distance between the 2 rival ions, so the chloride ion will discharge and give chlorine. So the statement A statement sounds correct. During the electrolysis of dilute sulfuric acid, oxygen is produced at the cathode. So oxygen comes from the OH ions, and the OH ions are the anions. They will be moving towards the anode. So if you want oxygen, then it will be produced at the anode, not at the cathode. That's a wrong statement. When aqueous copper sulfate is electrolyzed, the reaction takes place at the cathode. So at the cathode, copper sulfate you're talking about, at the cathode, you have copper 2 plus ions. It's not copper positive ions. So here the charge on the copper ion is wrong, right? So because of that, the statement will be wrong. When an aqueous copper sulfate is electrolyzed using the copper electrodes, that is a scenario of an active electrodes, the mass of the anode at the end of the reaction will be greater than the beginning. It's the anode which dissolves, anode which lose its mass, but the cathode, it will gain. The plating is always done at the cathode. So cathode will gain the mass. So it is the other way around. That's why we have D statement wrong. A is absolutely correct. Moving on to the question number 15. Here is again the case of electroplating. Now the pattern shown is set up to plate a steel key with a copper. So copper should be at the anode. Anode, it is the one which is basically at the positive terminal. So this is a wrong arrangement. So key should be at the cathode. It should be at the cathode, and the copper which is being deposited on the key should be at the anode. So this is not indicating that this is an anode. Okay. So the key does not get coated with the copper. Which chain need to be made to plate the key? So increase the concentration of the copper to sulfate. No, that has nothing to do. This is a wrong arrangement. Increase the voltage. Again, going to help you with more of coating, right? Replace the solution with dilute sulfuric acid. This is not going to act as an active electrode. If whenever we have an anode dipped in an own salt solution, then only it's going to act as an active electrode, and the plating will be done. So this is again a wrong option here. Moving on to the last part, reversing the electrical connection. Yes, of course, this has to be the positive terminal to which the anode has to be connected, whereas this is a negative terminal. So reversing the electrical connection is going to help us with the coating of the key. So answer will be D. Coming to the question number 16. The equation shows the reaction of glucose with oxygen. So glucose reacting with oxygen, producing carbon dioxide and steam or water. Which statement about this reaction is correct? Now, this is glucose converting basically glucose, when react with the oxygen, is giving you carbon dioxide and water. It's reverse of photosynthesis. When you talk about the photosynthesis, it's the carbon dioxide and water react to give glucose and oxygen, and this require the sunlight here. It's a reverse. So it's a reverse process of photosynthesis, and it's basically known as respiration. So it occurs in the dark. It's not an endothermic because it's a reverse of photosynthesis. It needs a chlorophyll as a catalyst. Catalyst is needed for the photosynthesis, which is a reverse of this. It occurs in plants, but not in animal. This happens in animals also because it's a respiration. So that is again wrong. So the correct answer is basically A. Question number 17 is about the energy profile diagram. They have mentioned for a chemical reaction here. So always remember, if we have the reactant level down there and the product level up there, so the reaction is always an endothermic reaction. Endothermic reaction. And endothermic reactions are the ones which take heat from the surrounding. So let's see which statement is correct. The reaction is an exothermic reaction. It's wrong. It's endothermic reaction because the reactant level is below the product level. Now, X represent the activation energy. Yes, X will represent the activation energy because activation energy is the amount of energy needed by the reactant to convert into the product. Okay? That's the amount of energy needed by the reactant to convert or to change into a product. So yes, X is a activation energy. Y represent delta H for the reaction. Y is delta H for not for this reaction, but if we have a reverse reaction, if we have the reverse process, then Y will be not the delta H, but that will be the activation energy. So C is again incorrect. Z represent the energy given out. So for endothermic reactions, we always take in energy, we don't give out energy. So that is why the D option is also incorrect. Moving on to the question number 18, it's related to the Haber process. The reaction shows, the equation shows a reaction for the manufacturing of ammonia, where N2 plus 3H2 giving you 2 ammonia. Which change will decrease the activation energy of the reaction? Which will decrease the activation energy of the reaction? Now, yes, addition of a catalyst. We say that the catalyst always lowers the activation energy by giving an alternate pathway. They give you alternate pathway, and because they give you an alternate pathway, they lowers the activation energy. They lowers the activation energy. So we have the correct answer A. So none of the other options are going to relate to the activation energy decrease. Moving further, we have question number 19. And question number 19, I'm reducing the size of the paper so that the whole question is on the screen. So we have it here. The apparatus shows a method of following a rate of reaction between the magnesium carbonate and the dilute nitric acid. So this is basically a reaction, and they have the reaction is taking place between magnesium carbonate and dilute nitric acid, and they have shown a gas syringe. So definitely carbon dioxide is being collected here. Carbon dioxide is being collected in the gas syringe, right? The graph shows the volume of the gas being collected against time. So they have a stopwatch. So they are collecting a data. Time against volume has been collected, and that has been produced in the form of a graph here. So it says that 3 statements are made about the experiment. The mass of the flask and its content decreases at the time as the time increases. So yes, because the magnesium carbonate and nitric acid are being, they're reacting, they're releasing carbon dioxide, and carbon dioxide being collected in the gas syringe separately attached to this. So definitely there's going to be the loss in mass, the decrease in mass with the time increase. One will be correct. The rate of the reaction decreases, the time increases. Yes, because initially the amount of reactants were more. So when they had more of reactant, there were more of collisions between the reactant particle. But as the reaction proceeds with the time, so there are lesser reactants, so their collisions were reduced, and therefore the rate of reaction will decrease. The reaction has finished after 4 minutes. So let's see, here we are getting a straight line. Straight line is an indication that the reaction has stopped. Yes, at the 4 minutes, the reaction has stopped. So we have all 1, 2, and 3 correct. So we have the correct answer for 19. That's basically A. Zooming back to normal, let's have the question number 20 now. Question number 20 is aqueous bromine is added to sodium chloride. It's the bromine being added to NaCl. Okay, so we have one halide and we have another halogen, the reaction between the two. So this can be a displacement, something related to the displacement reaction as well. Which statement is correct? Now, bromine, if you remember that when you talk about the halogens in the group, we have fluorine on the top, fluorine, chlorine, bromine, and then we have iodine there. So this is the most reactive, right? So on the top, we have the fluorine, most reactive, and the iodine is basically least reactive in group 7 of the, which are generally known as halogens. So bromine cannot displace sodium chloride at all because bromine is comparatively less reactive than chlorine. So let's see, the bromine is oxidized and the chloride ion are reduced. So that's not possible. Bromine is oxidized. Oxidation means, is it going to lose electrons? It is not. Now let's see, bromine is reduced and the chloride ions are oxidized. No. Now, correct is answer is C. There is no reaction taking place here because neither the oxidation nor reduction, because bromine being less reactive cannot displace the chloride from sodium chloride. So it's neither the oxidation nor the reduction is taking place. Sodium ions are oxidized. That's again incorrect. So the correct answer is basically C, 20C. Moving ahead to question number 21, which statement is correct for all the reversible reactions that have reached dynamic equilibrium? So what is dynamic equilibrium? We need to understand first. So dynamic equilibrium is a state of reversible reaction where the speed of the forward reaction is same as the speed of backward reaction. Number one. Number two is that whatever the amount of at the dynamic equilibrium, the amount of reactant and the amount of the product that remains unchanged. So it's seen from outside that there is no reaction taking place. So they are not saying that the amount of A and B is same as C and D. They're saying whatever the amount is at the dynamic equilibrium, that remains constant. And the amount of CD, why, what is happening? A and B combining to give you C and D, and reverse of that, C and D is combining to give you A and B. तो आपका ए एंड बी कंबाइन करके प्रोडक्ट दे रहा है, प्रोडक्ट डिसइंटीग्रेट करके ए एंड बी, तो आपका जो अमाउंट, whatever the amount of A and B is there, that remains constant. Similarly, C and D also remains constant. So that is a very important aspect of dynamic equilibrium. So let's check it out. The answer here: introduction of the catalyst changes the position of the equilibrium? Never. So that there are three factors which change the equilibrium, that is the change in concentration, change in temperature and pressure. So catalyst has no role to play. The catalyst will only speed up the reaction. The number of moles of the product equals to the number of moles of the reactant. We are not saying equal. We are saying the moles of the reactant and the moles of the product, they remain constant. There is no change. Let's see the third part. The rate of the forward reaction equals to the rate of the reverse reaction. Yes, that is the correct answer. So the rate, the speed of the forward and backward is right, correct, is same. That is why it has acquired the dynamic equilibrium. When the reaction reaches the position of equilibrium, the reaction stops. No, nothing of that kind happens here. So 21, answer is C. Coming to the question number 22. Which statement about the acid and bases is correct? We have question number 2, 0.1 mole per dm cube of ethanoic acid has a higher pH than 0.1 mole solution of hydrochloric acid. Yes, the strong acids, they have a lower pH, and hydrochloric acid is my strong acid. So strong acid, they have a lower pH, right? And the weak acids, they have a higher pH. So option A is correct. Coming to, let's read the rest of them also. What's incorrect? Let's check it out. All bases dissolve in water to produce OH ion. All bases are not soluble in water, so all bases will not dissolve, right? So soluble ones are known as alkali. The insoluble ones are still known as bases. So that all is incorrect with it. Base react with the nitrates to produce ammonia. That's again incorrect. Oxides of metals are always acidic in nature, not necessary. We are some of the oxides of basically the metal oxides are basic in nature, right? So they are not acidic in nature. So non-metal oxide which are acidic in nature. Coming for further, we have the question number 23. 23 is which compound can be formed by the precipitation reaction? So the precipitation, we have to check which salt is insoluble. You have to memorize that which salts are insoluble. So out of A, B, C, I can see group 1 salts are all of them are soluble. So potassium is again belong to group 1, so that's soluble. And all the nitrates are again soluble. So I have lead sulfate, which is basically insoluble and will be prepared by the precipitation reaction. Coming to the question number 24, which method could be used to make pure sample of copper to sulfate? We need to know that the copper is below the hydrogen in the reactivity series. We have to memorize the reactivity series. which is going to help us to solve questions related to metals, question related to acids, question related to electrochemical series as well. So when you talk about, so copper is below hydrogen. So because it's below hydrogen, so copper as a metal will never react with any of the acids, right? So directly copper as a metal will not react. So it's the copper compounds, either in the form of copper oxide or in the form of copper carbonate or in the form of copper hydroxides. They will be reacting with acids to form copper to sulfate, right? So let's check it out. Question number 24, we have acid and metal carbonate. Yes, we can have a copper carbonate that can react with sulfuric acid to form the copper sulfate. Acid plus, which method could be used to make acid plus metal oxide? This can also react, but acid and metal will not react, as I told you here. And similarly, this is not going to be precipitation reaction, okay, because you are getting a soluble salt. So this is not so 1 and 2 are correct. So option A is correct. Moving towards the question number 25, and I'll reduce the size of the screen again so that the whole question is there in front of me. The question says, the ammonia is made by reversible reaction. So this is a double-headed arrow, which is telling you it's a reversible reaction. And it is also indicating that delta H value is minus 92. That is indicating that the forward reaction is an exothermic reaction and the backward reaction is going to be the reverse of that, that's endothermic. So this is an information which we are getting from the equation. Now it says that a chemist investigated how the percentage of ammonia at the equilibrium changes with pressure. So highlighted thing is pressure. When your pressure is changed, so how the percentage of ammonia changes. And the experiment was carried at two temperature, that's 250 and 350. One thing very important, we need to understand, these are the two temperatures at which the experiment will take place. According to the equation, we have the forward reaction, which is an exothermic, and exothermic reactions always facilitate low temperatures. So that means the yield will be more with 250 degrees Celsius, right? So yield will be more with 250 degrees Celsius. Here I'll be getting more yield because I know the forward reaction is an exo. So keeping that in mind, an increase in pressure, we need to see again, there's a concept in the reversible reaction that the increase in pressure always increase in pressure always favors the reduced volume. So in this scenario, let's check it out. We are getting 4 volume here. We are getting 4 volume here. 1 plus 3 makes it 4 volume of gases, and we have 2 volume. So when we'll increase the pressure, it definitely is going to favor the reduced volume. That means जितना भी आप pressure increase करेंगे, ये reaction forward ही जाएगा, because forward direction में you have 2 volume here. So we have two things here, that the forward reaction is going to be facilitated at 250 and at increased pressure. Okay. So keeping that in mind, let's look at the particular option. 350 will never, it's on the y-axis, we have the percentage at equilibria. Okay. And here we have x-axis, we have pressure. So 350 will never give us a maximum yield because, as I've already said, the forward is exhaust. So 250 is going to facilitate more yield off. Now, yes, this is correct. 250 will give more and the increase in pressure is going to give more. So my option B will be my correct answer. So B is the correct answer in this scenario. All right. Moving back, zooming back again, coming to the next question. That's question number 26. 26 says that which statement about sulfur dioxide is correct? We need to know that sulfur dioxide is a reducing agent. And ionification test of sulfur dioxide is that when you pass the gas to acidified potassium, permanganate, it changes its color from purple or pink to colorless. So that is an identification test. They have often asked that in your exams. Now, which statement about sulfur dioxide is correct? Let's see. It is dissolved in water to make sulfuric acid. No, it's not sulfur dioxide. It's the sulfur trioxide which dissolves to produce the sulfuric acid, and the sulfuric acid is used in the car batteries. So it's a sulfur trioxide, not the sulfur dioxide. It is the final product of the contact process. No, it's not a final product of the contact process. Then we have the next. It is used as a food preservative. Yes, that's the correct answer. So sulfur dioxide के जो uses हैं वो एक है, it's used as a food preservative. It's used to bleach the wood pulp. Okay, it's used to bleach the wood pulp. Plus, it is used as disinfectant. It is also used for sterilizing babies' bottles. Okay, babies' bottles. So these are some of the uses of sulfur dioxide. And aqueous potassium iodide, no, as I said, this is a reducing agent, and potassium iodide is also a reducing agent. So there's no impact of sulfur dioxide on another reducing agent. So that's why D is also incorrect. Coming to question number 27, 27 says that the diagram shows a part of the periodic table which two letters represents element that can react together to form covalent compounds. So covalent compounds are always made between two non-metals, right? So two non-metals are on the right-hand side of the periodic table. So we have Y and we have X. If this is group 8, if this is group 8, this is group 7, and this is group 6. So it's 6 and group 7. Now, group 6 and group 7, these are two non-metals. So we have Y and Z, Y and Z. That means D answer will be correct in this scenario. 27 is D. Moving to question number 28. Which statement about some of the element in the periodic table is correct? 28, we have the element germanium in the group 4 has less metallic characteristic than the gallium in group 3. So we have, this is group 3 and this is group 4. So as we move from left to right, the non-metallic characteristic increases or enhances. Okay, it enhances, and the metallic characteristic, they decreases. So group 4 has less metallic characteristic, yes, and they will be developing more of non-metallic characteristic than your gallium in group 3. So A is absolutely correct. Let's see why B, C, D are incorrect. Group 5 will be having a charge of -3 because they will be acquiring 3 electrons to have a complete octet. C, element in the same group reacts in a similar way because they all contain the same number. No, it's the same valence electrons they have, the outer shell electrons. So the valence electron is missing out, otherwise the statement is correct. The transition metal elements are given this name as they easily change from solid to liquid. Absolutely no. Moving on to the question number 29. It says that these statements are about the halogens. All halogens are non-metal and diatomic molecules, correct? Chlorine displaces both bromine and iodine. Yes, because chlorine is above bromine and iodine. So it being more reactive will displace the less reactive from the salts, right? So that is again possible. The halogens become more reactive as they descend down the group 7. Absolutely no. The down at the bottom one, the bottom halogens, they are the least reactive ones, right? So that statement 3 is incorrect. Which statements are correct? 1 and 2 are correct. Answer is B. Moving on to the question number 30, which two statements indicate that the metal M may have a proton number between 21 till 30? So between 21 till 30, these are basically, check your periodic table for this. These are your transition metals. Okay, these are your transition metals. And transition metals have some peculiar characteristic. Okay, they have different properties. Uh, some of the properties they differ from group 1 and group 2, right? Which statement indicate that the metal M may have a proton? This that means which statements prove that they are the transition metals. So conducting electricity, all metals do. All the metals do, so not specifically for the transition metals only. Then we have the next one. It does not react with the water. Some of the transition metals, they do react. It formed two basic oxide with the formula MO and M2O3 that shows they have a variable valency. So yes, the variable valency is a special characteristic shown by the valence electrons. So 3 is correct. It formed two colored sulfate. Again, the transition metal compounds are colored. So 3 and 4 are correct. So we have the D option correct here. Next question is question number 31. And this is, it gives you the property of the four metal P, Q, R, and S. Now, the method of extraction they have given, the reaction with water they have given, and the reaction with acid they have given. So this question is related to the reactivity of different metals. Now, first of all, when you talk about the electrolysis, so when you talk about potassium, sodium, okay. So this is your reactivity series. Till aluminium, these elements, they are extracted by the process of electrolysis. And then till here, they are done by reduction process, reduction by reducing agent. And these elements are extracted just by simply heating their compounds thermally, right? Thermally, when you heat them. So their extraction is done thermally. So when you talk about the P and Q, they seems to be more reactive. They seems to be on the top because we know the method of electrolysis extraction is electrolysis. Okay. Now let's see. Then the reaction with water, and here the reaction reacts speedily with steam. So it is not going to react with water. So that might be aluminium because aluminium has an oxide layer on it. So we can guess that this is less reactive. This is P and R is somewhere above P. Coming to the next Q and S, further let's see, reacts slowly and reacts rapidly. So definitely R is more reactive and P is less reactive. Then we have the next option, Q and S. They both are being extracted when you heat their oxide with carbon. Okay. So, but further, when we move on, so that says that reacts slowly with steam and reacts slowly with an acid, whereas the S shows no reaction with water. So S is below here, S is below, and definitely Q is above here. So this is how we sequence them, right? Now let's check it out, their options, which is going to be correct, which statement is correct. P is least reactive. P is not least reactive, so A is incorrect, right? Then we have Q would displace R from the solution of its salt. Q will displace R from its salt. Q is less reactive. How will it displace? So again, this is wrong. R could be zinc. R cannot be zinc because R belong to the top metals which can be electrolyzed, which are extracted on electrolysis. It's not in the center chunk. So R cannot be a zinc. S could be copper. Yes, S could be copper because S belongs because it's extracted by heating its oxide. So S is somewhere here. So S can be a copper. So I think the option is D. The correct answer will be D. Moving on to the question number 32. Which statement about extracting metal from the ores are correct? Aluminum extracted by the process of electrolysis of aluminum oxide dissolved in oxygen. So 1 is correct. So aluminum can be, it is extracted by electrolysis absolutely from aluminum oxide, and we add cryolite in order to reduce its melting point from 2000 to 950 just to make the process economical. Silver is difficult to extract from its ore because of its low reactivity. No silver can easily be extracted just by heating its ore. So it's easily, it can be extracted, thermally extracted. So it's not difficult at all. So difficult, it's not difficult. Coming to the question number part 3, iron is extracted from hematite by the reduction in the blast furnace. That's absolutely correct. So 1 and 3 are correct. So we have the correct answer. That's B. Moving to question number 33, we have the which statement about the corrosion of iron are correct. So it says the corrosion can be prevented by coating with iron and zinc. So if you coat it with more reactive metals, then definitely you can prevent it from rusting. But iron and zinc, coating the iron with zinc, okay, zinc is more reactive. Yes, you can coat the iron with zinc. That's a possibility in order to prevent it from rusting. Corrosion only occurs in the presence of air and oxygen. Yes, for rusting, you require oxygen and you require water. So oxygen comes from air. So second statement is also correct. Rust is an alloy of iron and oxygen. Rust is not an alloy. It's a substance, or it's a compound. Sacrificial protection occurs when an iron is connected to less reactive. It's not less reactive. It's basically the more reactive, either magnesium or zinc. If they're attached to the metal iron, so they get rusted off first, and they sacrifice themselves in order to prevent the iron from rusting. So we have option 1 and 2 correct. So A is the correct answer for this MCQ. Moving to question number 34. The 34, it says that in the extraction of aluminum from the aluminum oxide, the 3 reactions, they take place here. 1, 2, and 3. Now they're asking which reaction takes at the positive electrode. Positive electrode means your negative ions will be going towards it. So if it is aluminum oxide, so aluminum ions and the oxide ions are there. So definitely oxide ions will be going towards the positive electrodes. And electrodes are basically made up of, whether positive or negative, they are made up of carbon. So because oxide ions are going there, so first thing is that the oxygen is being liberated. Secondly, when the oxygen liberates there, so the carbon electrodes, that's a side reaction, they combine to form carbon dioxide. So the two reactions will take place at the positive electrode, which are made up of carbon. Number 1, the oxide will be giving you oxygen. Number 2, the oxygen which is being liberated combined with the electrode carbon and will be forming carbon dioxide through a side reaction. So 2 and 3 are correct. So we have the option D correct for the question number 34. Then we have the next one. Which statements are, again, they're asking you are correct. Chlorination is used to remove the unpleasant taste from the drinking water. So for the unpleasant taste, we have the charcoal, right? We have the charcoal. We pass them over the charcoal bed in order to remove the bad, unpleasant odor and the taste from it. So that is incorrect. Desalination can be achieved using distillation. Desalination, yes, for the distillation we have to go for desalination we have to go for distillation. That's correct. The presence of the phosphate in water and soil encourages the plant growth. Yes, that's again correct. The phosphate come from the detergent or from the industrial discharge. So 2 and 3 are correct. So we have the C option correct for question number 35. Moving ahead towards the next 4 questions, which are from organic chemistry. 2 isomers are shown. What are isomers? Isomers are the compound of the same with the same molecular formula. Isomers, they have the same molecular formula, but they have different structural formulas, right? So such substances are known as isomers. So these are two isomers. Which statement about these isomers are correct, right? So let's check it out. Do they have the same molecular formula? 1, 2, 3, 4, it's C4, and then 3, 5, 6, 7, 8, 9, 10. C4H10. And this one again, 1, 1, 2, 3, 4, okay? 3, 3, 6, 9, 10. Yes, they both have the same molecular formula. They both are isomers. Now, they have the same empirical formula because they have the same molecular formula. So definitely they will be having the same empirical formula as well. So one is correct. They have the different molecular formulas. No, their molecular formula is same. That's C4H10. They don't have the different molecular formula. That's wrong. They have different structural formulas, right? Now, they are the members of the same homologous series. They don't have any other functional group. Only the single bond is here. They belong to the alkanes. Both of them are alkanes. So they belong to the same homologous series. So 1 and 3 are correct. So option B will be correct for the MCQ number 36. Moving to the 37 now, which is again from organic chemistry. The 37 states that a hydrocarbon compound Q has an empirical formula C6H5. Okay, it's an hydrocarbon. Q reacts with hydrogen to form a single product with a molecular formula CXHY2. So CXHY2 is a formula, is a general formula for alkanes. It's a general formula for alkanes. Which statement about Q is correct? Now, Q does not burn in air, so all the organic compounds, they undergo combustion. So that is absolutely wrong. So Q will also burn in air, so that's wrong. Then we have Q is a saturated hydrocarbon. Now they're saying that a reaction with hydrogen and it's a hydrocarbon. So we have only two hydrocarbon. One is an alkane and another one is alkene. So alkane only undergo reaction with halogens. So, and that because they are saturated in nature. So they only undergo reaction with halogens. Whereas when we talk about alkenes, they undergo reaction with hydrogen, they react with water, they react with bromine, right? So they undergo reaction with the halogen as well. So now out of these two, I think alkane will be incorrect. It's an alkene. So they say that when an alkene react with hydrogen, they give you alkane. That's absolutely correct statement if we consider Q as an alkene. Now, which statement about Q is correct? So Q is a saturated hydrocarbon, which is again going to be incorrect because saturated hydrocarbon are alkanes. Alkenes are unsaturated. So B is incorrect. Q reacts with the bromine to give you a single product with the molecular formula C6Hy minus 1Br. So this general formula is wrong because when an alkene undergo hydrogenation, they give you alkane. And the general formula for an alkane is CnH2n plus 2, right? So this is the wrong formula. Q react with the steam to form a single product with the molecular formula CHY plus 2. Yes, when an alkene, they reacts with water, they give you alcohols. And alcohol's general formula is CnH2n plus 1 OH. So this H is also when added to this, so instead of plus 1, अगर ये वाला H जो है आप इसके साथ add कर देंगे, so this will become plus 2. सही है? तो इस H को हटा दीजिए, so this will become CnH2n plus 2. So that will be the general formula. That can be the general formula for an alcohol. So our D option is correct. Now coming to the question 38, the structural formula represent an alcohol. For an alcohol, we have to look for hydroxyl group. So this is only oxygen. This is not an alcohol. This is OH. Yes, B is an alcohol. Here, this is C double bond OH. So this is COH. This is not an alcohol, right? So it's a part of COH, right? So this is your carboxyl group, which is a part of which makes it a carboxylic acid. So D is incorrect, and again, we don't have it here. So question number 38, B is the correct answer. Question number 39 and 40, just two more left. Question number 39, which statement about the carboxylic acid is correct? They are prepared by oxidation of an alkane. No, they're prepared by the oxidation of alcohol. So that is why this went wrong. Question number part B, they decolorizes bromine water. No, the carboxylic acid will not decolorize. It's the reaction of an alkene. They decolorizes bromine water. C, they react with an alcohol to form an ester. Yes, definitely alcohol and carboxylic acid, they combine to form an ester. So C is correct. They react with the carbonate to form salt, water, and carbon dioxide. Water and carbon dioxide, not hydrogen. So that's why the D is incorrect. And here comes the last question. And the last question is related to the polymer. P is a polymer that has 6 carbon atoms in each of the monomer from which it is being formed. It's not a polyester. That means it does not have an ester linkage. Now, what is an ester linkage? Ester linkage is C double bond O and O. So it does not have an ester linkage. So this should not be present, right? It is formed using a condensation polymerization. So that means the two monomers should be different, and whenever they connect, there should be an elimination of water there. So D is incorrect because that's a product of your addition polymerization. ये प्रोडक्ट जो है ये आपका एडिशन पॉलीमराइजेशन का प्रोडक्ट है, ये एडिशन पॉलीमर है, क्योंकि आपके यहाँ पर कोई लिंकेज नहीं है. नीदर यू हैव एन एस्टर लिंकेज नॉर यू हैव एमाइड लिंकेज हियर. दिस इज योर एमाइड लिंकेज, राइट? सो जब एस्टर लिंकेज नहीं है उसके पास, तो क्या होना चाहिए? इट शुड हैव एन एमाइड लिंकेज. So let's check it out. Do they have an amide linkage? Because in Olevels, we only do these two cases. Either they should have an ester linkage or they should have amide linkage. If this is not present, then must be amide linkage. So D is an addition polymer without an amide linkage in it. So ये आपका, this is your ester linkage. So ester linkage वाला polymer वो नहीं है. So again, A is incorrect. Now we have to look for the amide linkage. Yes, here we have an amide linkage. This is correct. Here again we have an amide linkage. This is also correct. So it can be either B or it can be C. But now what is there? We also have to check, does the monomer has 6 carbon in it? So let's check it out. It's 1 times 6. So 6 carbon are here, but this is going to be the 7th one. ठीक है, अगर हम इसको इस तरह से split करते हैं, so this is one monomer which is coming from carboxylic acid and another monomer which is coming from amide. So amide has 6 carbon in it, but the carboxylic end has the 7 carbon in it. So B cannot be an answer. Similarly, if we split it apart at the midpoint of the linkage, making the C double bond O forming a monomer carboxylic acid, let's check it out. It's going to be 4 carbon here, plus 1 carbon coming from this side and 1 from this side. So altogether 6 carbon here. And here we have again 6 carbon. So both the monomers have 6 carbon in them, present in them. Plus it has an amide linkage. Plus it's not an addition polymer. It's formed because of the condensation polymerization. So answer to question number 40 is C. I hope you enjoyed the session with me. So if you enjoyed it, please kindly like and subscribe the channel. Thank you so much.